Today we're going to look at solving compound inequalities. All right, so your standards, again, very much the same in this whole unit. And your success criteria: write word sentences as compound inequalities, solve compound inequalities, and graph solutions of compound inequalities. So you can see that everything we're doing today has to do with compound inequalities. So what is a compound inequality? Here's your vocab. A compound inequality is an inequality formed by joining two inequalities with the same word, and or the word or. So and or, these are words that we're going to get familiar with looking at compound inequalities. All right, we're going to look at how to describe a few intervals on the real number line, but first let's look at words and math. Okay, sometimes understanding what the math problems are can go a really long ways in helping you figure out how to solve these. So the word compound, remember we're doing compound inequalities. The word compound can have many meanings, such as a chemical mixture, a group of buildings, or a word made from more than one word. All of these meanings have something in common. They represent something that is made from more than one thing. All right, so more than one thing. So remember, compound, more than one inequality. All right, so the graph of a compound inequality with and is the intersection of the graphs of inequalities. Remember, intersection means they overlap. The graph shows numbers that are solutions of both inequalities. All right, so x greater than or equal to 2 and x less than 5 can be written as 2 less than or equal to x is less than 5. So you can take these two individual inequalities by adding the word and, make it a compound inequality, and this bottom graph here shows that these are all greater than or equal to 2 and less than 5. Okay? All right, so the graph of a compound inequality with or is the union of the graphs. The graph shows numbers that are solutions of either inequality. So these show both, and this shows either. So y less than or equal to -2 or y greater than 1. You can see all of these are less than or equal to -2. All of these are greater than 1. Because this is a compound inequality with the word or, these will be graphed on the same number line, but you can see they go in opposite directions here. All right, so know the difference between and or when it's related to compound inequalities in math. All right, so over here, let's describe these. The first one up here, letter A, has half open interval. Okay, so you can see this one's a closed circle, this one's an open. Because the shaded area is in between, we can determine that this is an and statement. So let's use the variable x. X is greater than or equal to -6 and less than 3. B part would be an or statement because they're going in opposite directions. They do not intersect. All right, so we're going to write this as a union. So let's use y. So y is less than or equal to -6, or y is greater than 3. Okay, so it's not both, it's one or the other. All right, C part would be an intersection again. So this one would be an and statement. X is greater than -5 and less than or equal to +4. D part would be an or statement. X is less than -5 or X is greater than or equal to +4. So less than -5 or greater than or equal to +4. All right, so you should practice the rest of these on your own just so you can determine whether these are and statements or statements. All right, example 1. Write each sentence as an inequality, graph each inequality. All right, so very similar to what we've been doing. The only difference is these will be compound inequalities. All right, so it says a number x, okay, a number x is greater than -8 and less than or equal to positive 4. All right, because this has the word and, we can write this as a compound inequality. So we're going to we always put the negative or the smaller number on the left, so -8 and 4, and then x goes in the middle. So you can see that this inequality here drops straight down because the variable did not change sides. On this side, we switched to -8, and now x is on the opposite side of -8. So this is going to reverse. So x greater than -8 is the same as -8 is less than x. All right. All right, to graph this inequality, just like on the previous page, let's have 2, 4, 6, 8. -2, -4, -6, -8. All right, so the compound inequality for part A says that -8 is less than x, and x is less than or equal to 4. So we're going to need an open circle at -8. Okay, x is greater than -8, so it's going to go this way. And x is less than or equal to 4, so we need a closed circle at 4. So everything in between -8 and 4 would be considered a solution to both of these inequalities. When it's an and statement, it's a solution to both this one and this one. All right, B part says a number y is at most 0. Okay, at most 0 would mean less than or equal to or at least means greater than or equal to 3/2. All right, so because this is an or statement, you cannot write it as a compound inequality like the one above. So we're just going to graph. All right, so we've got 0. Let's do 1, 2, 3, 4. All right, so we have y less than or equal to 0. So we're going to have a solid circle on 0. Less than or equal to will be shaded to the left. Or y is greater than or equal to 3/2. So 2 goes into 3 once, 1 left over. So 3/2 is the same thing as 1/2. This is a solid circle because, again, it's greater than or equal to. Greater than 1/2 would be 2, 3, 4, and so on. So I'm going to shade this one to the right. All right, so solutions to this compound inequality would meet this or this requirement, okay? So compound with and has to meet both, okay? They're overlapping. It makes both of these inequalities true, or makes one or the other true. All right, next example, solve each inequality, graph each solution. So we have -4 less than x minus 2. This is an and statement because they overlap. So we're going to have and. The middle goes with both, x minus 2 less than 3. And we have to solve both. So we're solving for x. We're going to add 2 to both sides. -4 plus 2, -2. And here we're going to add 2. You get x less than 3 plus 2 is 5. All right, so if you want to write it as a compound inequality again, just put the two together. You only need one x in the middle, but that will represent your compound inequality of 0, -1, -2, -3. All right, I need an open circle for both -2 and 5. And it's an and statement, so everything's going to be between -2 and 5. So all the numbers in between -2 and 5 are solutions to this compound inequality. All right, the next one, -3 less than -2x plus 1 and -2x plus 1 less than or equal to 9. All right, subtract 1 from both sides. Divide by -2. All right, I divide by negative. Remember, when you divide by negative, you got to switch the inequality. -4 divided by -2 is +2. Here I'm going to subtract 1. -2x less than or equal to 9 minus 1 is 8. Divide by -2. Again, I divide by -2, so I'm going to switch my inequality symbol to greater than or equal to -4. All right, so I always try to put the smaller number on the left side, so I'm going to bring my -4 over here. Okay, it's going to be less than or equal to x less than 2. So all I did was take this right here. I took the x, it still goes here, but because I moved the -4 to the other side of the x, this switches. And same thing over here. I switched the 2 to the other side, and I did that because -4 is smaller than 2. And when you write an inequality, you just write it from left to right, just like you do equations in English class. So let's have 0, -2, -4. All right, so we need a closed circle at -4 because that is less than or equal to, and an open circle at 2. And again, we need everything between those two inequalities. Everything in between -4 and 2 is part of the solution set, including -4. -4 is part of the solution as well. +2 is not, because it is not included.